Alright, let's look at the trig derivatives. Alright, so derivative of sine function is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared of x. Alright, derivative of cotangent is negative secant squared. Right, negative cosecant squared. And derivative of secant is secant tangent. Derivative of cosecant is negative cosecant cotangent. Right, you can see that there's some pattern going on. Right, so one obvious pattern is every time you take the derivative of something that starts with a c, it's all negative. Right, then sine cosine kind of goes back and forth. And tangent secant has something to do with each other, and the cotangent and cosecant have something to do with each other. All right, so let's verify some of them. I don't have time to go through all 6, but we can do at least, let's see, we can do maybe sine usually given in the textbook. So let's try to verify derivative of cosine. All right, so let's do that. Alright, so it's a proof, so let's try to write the proof of, so this is, I'm going to just let's say number 2, alright, so this is number 1, number 3, number 4, number 5, and number 6, alright, so proof of number 2, alright. So we want to find the derivative of cosine of x. All right, so I'm going to go through the definition first. So you have a limit as h approaches 0. All right. Then you have a cosine of x plus h minus cosine of x. All right. All over h. Alright, got that. Alright, then what we want to do is we want to use the trig identity. Remember that when you have a cosine of, say, a plus b, which is equal to cosine of a, cosine of b, minus sine of a times sine of b. Alright, so let's use that to break this guy down right here. Alright, so this is going to be equal to, right, limit as h approaches 0. Alright, so this is going to be cosine of x times cosine of h minus sine of x times sine of h, and then minus cosine of x. All right, then all over h. All right, then we're going to split this. Let's see. So I'm going to group these guys together. So this is this guy, and that guy has a cosine in it. All right. So I'm going to write it this way. So, whoops, I want blue. All right. So you have a limit as h approaches 0. Alright, so I'm going to pull out the cosine of x. This is in common. Alright, then here, what's left is cosine of h from here minus 1. And then you still have h on the bottom, so I'll probably have to put h on the bottom here. Alright, then what's left is minus sine of x times sine of h over, we still have to divide by h. Right? So we have this expression here, but luckily we know where these guys go. Right? If you look at the cosine of h minus 1 all over h as h approaches 0, this is the second one of the useful limit, and we know that this goes to 0. right? So this whole first term goes away. And here, limit of sine of h over h. So this is the first of the useful limit. We know that this goes to 1, right? So the limit is going to be, right? So you have a negative sine of x times 1. So negative sine of x. Then we are done, right? So we see that we could verify number 2. Right? Number 1 is very similar, so I'm going to skip that. But everything else, so once established number 1 and number 2, everything else is a combination of those. So let's try, we can probably do, well, let's do that number 5, right? I'm just picking those things randomly. So proof of number 5, right? So I'm going to assume that we have those two already figured out. So number 1 and number 2, right? So if you want to find the derivative of secant of x, right? Remember that the secant is simply a reciprocal of cosine. So we take the derivative of 1 over cosine, right? Then we can use a quotient rule. So you have square the denominator. So you have a cosine squared of x, right? Derivative of the top is 0 times bottom cosine of x. That's going to be 0 anyway, minus top is 1 times derivative of the cosine is, derivative of cosine is negative sine, right? We just prove it. So it's going to be, maybe I'll put negative sine of x. Right? You can see that the first term just goes away because multiplied by 0. And then we have double negative, so it's going to cancel. It's going to be positive. Right? Then what we can do is we're gonna so we want to get the secant. So I'm gonna use 1 of the cosine on the bottom and a 1 on top. So you have a cosine of x times we have another cosine on the bottom. So we put the cosine here, and you have a sine there. Right? Then we are pretty much done here. 1 over cosine is secant of x. Right? Sine of a cosine is tangent. Right? Which verifies number 5. Right? And all the other 3, 4, and 6 can be proven very, very similarly, and sometimes use a little bit of a trig identity. All right? That's it. I hope that this was clear.